Hello everyone, welcome to Connection Wednesdays. It's May 2nd and this is the last Connection Wednesday in the spring season. We are happy that we can meet each other again. My name is Jana and together with Adam, we are both product engineers at Idea Statica, and we would like to show you some very nice examples of steel connections modeled and code checked in our software. Before we start, I will again mention one practical thing. You are muted by default, and if you want to communicate with us, you are welcome to do that via questions panel. So if you have any question, please write it to this panel and we will try to answer them during the webinar or in the email after the webinar. So what will you see today? So one customer project. Today it's joined from tower mast by ČEPS, which is a big company in Czech Republic. And in the end, we will have a look at some new features of version 9. It will be the right-click mouse button. So what are you able to do with the right mouse button in new version? And now I would like to pass the word to Adam, who will introduce you the company and the project you will see today.
Hello, welcome everybody again to Connection Wednesdays. So let me introduce this company that we got the project example I'll be showing in a minute from. This is ČEPS. It's the electricity transmission system operator, and they build and maintain the infrastructure for the electricity distribution all around Czech Republic, and they're also, of course, connected to the other European countries. So that's what they do. And for the joint itself, this is how it looks. They were actually developing a whole series of new tower masts or the electricity towers, and they were designing the joints as well, of course. And with help of Idea Statica connection, they were able to redesign them and save about 20% or 30% of material that they would spend of that joints. So now let's see how actually you can model such a joint, which is kind of interesting because it's of course a non-standard joint, and it produces also some features like U-shaped plate and so on. So how can you do that in Idea Statica? So I will take the presenter and I will show you the process or the modeling. So I will start with the new project, of course, and I have prepared, just to cut some time, I have prepared the geometry, the basics. So I'll just let you browse through that. I started a new project under Eurocode, of course, and I've chosen the material of S355 steel grade. So then I set up a couple of members in the geometry part, and that's the main tube, CH, which is a tubular section 88.9 by 6.3 millimeters, set in the space in the right coordinates. There are two tubes connected to it, B70 by 5.6, and then a couple of L sections here down. Those are just standard L sections, 60 by 6, these two, and another couple, 45 by 4, this couple over here. And now the main member is set as ended, the geometrical type. And to mention, all the other members are set as the model type N and VZ. This is for the restriction that is only for the model. The beam is then loaded only by normal or shear force. And since this is a truss construction, truss beam constructions, there are only compression or tension forces. So that's why they are all set to this model type. Okay, so that's for the geometry part. This looks a bit strange, but we'll see during the modeling it will all align itself automatically to the right shape. So we can proceed to the load effects, and here I will use the shortcut or the import, of course, of the forces that I have in Excel sheet. So I just simply copy paste them. These are 3 load combinations that we will use, and here I click the import. Sorry, I just forgot one important thing, to turn on the loads in equilibrium. So we'll be able to load the main bearing member, the main tube as well, because we want to do that. So import, copy paste, replace to delete the blank one that was automatically added, and we get the 3 load effects here. This is the maximum tension, maximum compression, and non-symmetrical case of loading. We get the loads from, or the internal forces from a structure model, of course. So that's it for the load effects, and we'll just start the main modeling. So I'll add the first operation, and that will be a stiffening plate to create the main plate of the joint. So of course I will adjust its parameters and tilt it like this. And I go to the editor, and here I will just shape the plate a little bit by a bevel operation. So 45 for corner 1, and the same one just mirrored for the corner number 2. Okay, so this is shaped like this. And we can continue. I will now do this bottom part with the L sections. I will be connecting them with the gusset plate. So I will add operation gusset. I will choose the grade 8.8, M12 for the size of both. And here I will add the gusset plate, and then I will continue with other operations for connecting to connect the L sections. So the gusset plate will be set for the M6, which is one of the L sections related to CH, the main tube, of course, and I will just adjust the geometrical parameters. Alignment rear, welded, and here I changed the weld position of the main weld here, and leave the default size, which is calculated to be 3.2 millimeters. And I will turn off the weld that's connecting the L section because I will connect it in the next operation. This was just to create the gusset plate. Okay, so as I said, let's connect the L section. I will use the gusset plate operation again, but this time I'll be connecting M6 to existing plate, which is the gusset 1. And I will be I will, of course, change the parameters here, and I will choose the bottom plate to be aligned with a bolted connection. This will be the rear, like this. The bolt is okay, and now the position of it, like this. Okay, that's fine, and I will copy this operation and set it for the member M4, which is the another L diagonal, like this. And here I will change just the bolt size. I will use bigger bolt here, M16, like this. So we've got one of the half here, and now I will just copy these 3 gusset operations for the other side as well, just to mirror them. So I copy it. I'll just change the member to M7, new plate. Everything is the same here. We've got the gusset plate here. So I copy now the gusset 2 operation. Again, change to M7, gusset 4. I will change the alignment here to front. Okay, and that's it. And the gusset 3, I will assign to member M5 and front alignment. So we've got it there, and now we can continue with connecting the tubes to the main plate of the joint. So I will add now a new operation of actually the U-shaped clip plate to connect these tubular members to the plate. So how can we do that? We can, of course, use the stiffening plate operation. And here we could somehow figure or import the plate from the XF or things like that. Or I'll show you another, sometimes very useful because it's very simple, another way. Instead of using stiffening plate, we can use a stiffening member operation. And we can input the shape or the geometry as a member, which is sometimes quite handy, like in this case. I'll show you how to model a U-shape. If you go through the steps here, you get, of course, many options. You can compose it in the general cross-section editor. That's also possible. Import by DXF over here as a general shape, or just pick some of the, let's say, adjustable sections or shapes here and just optimize it to the desired shape. That's what I'm going to do now. So I'll pick this one. This is the general L shape, but I will change it like this. That's the size, thickness. And now the angle, if I input just 7, I can have something like this. So I can play with this. And I can get the desired combination. If I input 0, I get something like this. So I can just you know, adjust this to the shape I need. So I get it like this now. So what I need is to put it in the right position. So I do it that I change the origin to plate, and that will be the SP1, the main one. Set it as doubler and locate it as rear. Now I will change its size of this clip like this and modify or change the position of it by setting the X position and rotation. So we've got it just in there, just in the right place. Okay. Now I turn off the weld here because we'll be bolting it together. And I will continue now with the cut operation to weld the tube to this U-shaped plate. So let's do that. I will adjust the standard cut operation. And oh, I forgot about the connecting the main tube to the plate, so let's do that first. So I'll be connecting CH to the plate, SP1, and the method is surface, of course. Okay, and I leave the default size of the weld, which is 6.3 millimeters. And now let's connect the diagonal tube. So that's D1. We're connecting to member, because it's stiffening member, SM1, and cutting method surface. So we got it like this. Again, I leave the default weld size, which is calculated to be 5.6 millimeters. And now we'll just copy this plate for the other diagonal as well. So let's do that. I'll just change the rotation here, and we got it in position. I can take now the cut operation, just copy it and assign it to D1 and change this to SM2. Get the same cut. And the last thing will be just to add bolts here to connect those those 3 plates, or the U-shaped clip and the main plate. So I'll add operation grid, a bolt grid, and of course we'll connect in 3 items. First one is the member SM2 web 1. Second one is the stiffening plate number 1. And the third one is stiffening member web 2. Got the bolt somewhere here flowing, and so let's change its size to M20 and put them into the right position, which is -45, -70, and 45. Okay, that's good. And I just copy this and change this to SM1, SM1 web 2, SB1 remains the same. Okay, so we're done with this quite unusual or non-standard joint connections. And just let's calculate this now. Again, to cut the time, this will be calculating about 1 minute. I have this calculated here. So we can see the overall result display. You see all green and orange. That means orange is very close to the limit of capacity of these parts, like these welds and bolts, but still we pass the code checks. So we can just browse the results as usual. I think we don't have to go to any details. Let's, for example, click on this bolt, see the values and see the equations according to Eurocode. And I know we can just turn on the stress along with mesh, and